Hello everybody, so we are going to work on distance formula. Okay, it may end up being more than one page. So our distance formula, everybody, so we do use this with polygons, and so you are going to see this. So this is our distance formula. And I'll also show how it's related to Pythagorean theorem that we use. So you can use that version to help you find the distance as well. Okay, so how can we find the distance between 2 points? So this is our essential question. Between 2 points. And then in whatever coordinate plane. Okay. And we always put our date. Okay. So the distance formula, everybody, distance is equal to, and you're going to be like, oh, it's similar to what we were doing with slope. Yeah. So it's x sub 2. So x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay. So so this is the distance formula. So we're going to go ahead and put the points. So 2, 3, and then we have 7, negative 4. Okay. So I'm going to go ahead. Remember we said look at the x coordinates. Okay. So if I look at the x coordinates, 2 is less than 7. So that means this is going to be our first point. Okay. So we're going to go ahead and substitute it in. So remember labeling those points. I'm going to substitute them in. I'm going to go distance is equal to. So 7 minus 2 squared plus negative 4. Keep track of those lines, everybody. Minus 3 squared. Okay. So remember this is negative, so keep, change, change. Keep, change, change. Same sign, just add. So those two negatives we're going to end up adding together. Opposite sign subtract, so 7 minus 2 is going to be 5. Negative 4 plus negative 3, same sign, just add, so that's going to be negative 7. I'm going to square them. 5 squared is 25. Negative 7 times negative 7 is 49. And then we're going to add those two together. To get 74. And then everybody, this is where you can use the calculator, so decimal scientific. And we're going to round to the 10th place, so we're going to get 8 and 6/10. Okay, let me do, so we're finding the distance between 2 points. BTS, the abbreviation for points. Okay, so this one is going to be our first one. And we're also going to do another example. Okay, so we have 2 more points. So let's say we have a negative in here. So -4 and 7. And our second point is at 6, 3. Okay. So remember everybody what we have. So -4 is less than 6. So that means this is going to be our first point. So I label them. Okay. And then we're going to substitute them into our distance formula. Distance is equal to, we'll put it all in. So we're going to go 6 minus 4 squared plus 3 minus -7 squared. Okay, and then we're going to take and go keep, change, change, keep, change, change. Okay, and then we are going to go ahead and do those calculations. Okay, so 6 plus 4 is going to be 10. And then we're also going to have 3 plus -7, opposite sign subtract, so it's going to be -4. We add the sign of the larger number. 10 squared is 100. -4 squared is going to be 16. Okay, so it's going to be a square root of 116. Okay, so 116, everybody, you're going to take the square root of that. So go ahead and work on that one, everybody. Okay, so I got 110 and 7,700, so rounding. So 5 and up rounded up, so we're going to round it up to 10.8. Okay, so that would be the distance between those 2 points. Okay, let's do an example if we had Pythagorean theorem. Okay, so let's say we had 2 points. Put them on the graph. So everybody, when in doubt, graph it out. So we're going to graph it out. Let's add. When I taught algebra 2, she would say that when in doubt, graph it out. Okay, so -2, 4. And so that's our first coordinate, everybody. So -2, -4, and then we also have at 1, 2. So we have right here A, that 3, 2. Okay, so, and what we're trying to find, everybody, is the distance between these. So what I want you to notice, so we can go over and then up, different color. So we can go over and up between these 2 points. Okay, so we would go over, this would be 1, 2, 3, 4, 5. So this distance on the bottom is 5. And then we can go up. So we're going up 1, 2, 3, 4, 5, 6. So this length is 6. So this relates to our Pythagorean theorem. So the sum of the sides of the square of the right triangle are equal to the square of the hypotenuse. Okay. So our hypotenuse, everybody, is our largest side. 5 is our base. A is our other side. Because we know it's all about that base. Got that base. No trouble. Okay, so let's go ahead and put it in. So I'm going to put 6 squared plus 5 squared is equal to c squared. Okay. And I want you to see how this is related to a distance formula, because then to get rid of our c squared, solve for c, because we're solving for c, we take the square root. Doesn't that look like the distance formula? It does, everybody. So this is like the distance formula. So we're just going to take, so that's going to be 36. 6 times 6 is 36. 5 squared is 25. And then we're going to add them up. So we get square root of 61. Everybody remember we're going to round to the tens place. Okay. And we get 7/8100ths. Okay. 5 and up rounded up, so that means we're going to leave it at 7 8/10. Okay. And so that is our C, which is also our distance, everybody. Okay. So that's how this relates to the Pythagorean theorem. Okay. Let's do another example of Pythagorean theorem. Oh, change them over here. That's okay. Two, three. Get -1. Okay. Y or X. Okay, so this is 7. So this is going to be at 7 for F. So we're going to graph our trapezoid on our quadrilaterals. And that's at 1, -1. Is G. Okay, and then this one is at 1, 3 is D, vertex D, vertices D. And then we have E is at 5, 3. So E is at 5, 3. Goes down. Okay, so everybody, we can use this. So if we wanted to know the length of EF, so we wanted to know what that is. Okay, so if I go over 1, 2, so that distance right there, everybody, I counted over 2. And then I'm going to count up. So we're going to go 1, 2, 3, 4. So that distance right there is 4. Okay. So again, everybody, we can use Pythagorean theorem. So the sum of the squares of the right triangle are equal, or the legs are equal to the square of the hypotenuse. For right triangle, we call it sides legs. So we're going to substitute in. We're going to have 4 squared plus 2 squared again is equal to c squared. We're trying to find this length right here for EF. And I'm going to take the square root. Got to get to the root of the problem. Remember, what we do to one side, we got to do the other side. And then we're going to, so 4 squared is 16. 2 squared is 4. C squared is square root of C squared is C. Okay, so then we're going to take the square root of that. And we get, so 16 plus 4. Okay. It's going to be 20. Square root of 20, everybody, is 4. 4 sevenths. 5 and up rounded up. So we're going to round it up, everybody, to 4 and 5 tenths. Okay. So it's equal to approximately 4 and 5 tenths. And then that would be our C. That is our length of EF. Everybody, you got this.